Thanks for coming. So today I'm going to be covering how to run a validator. So my name is Trevor and I'm a software engineer at Celo Labs, working on the protocol and infrastructure side. So the plan today is to just, I guess, more show the setup that you would need in order to operate a validator. I think a lot of the steps that are required I've done before just because it takes time, setting up VMs, setting up firewall rules, but I will try to cover those in detail. So yeah, I hope that this could be like a resource in the future to look back on with recording as well. So for some context, this is for the Great Celo Stakeoff. So I'm sure a lot of the viewers are aware of this already, but what this is we have an incentivized testnet called Baklava, and we're running a game of sorts where it's split into separate phases, and the current phase is phase 1.1. So as of now, it's more of just like a playground for validators to get familiar with Celo. But once it hits a later phase, so phase 2, on January 8th, we'll start putting validators to the test, making sure that the setups are correct, that you're running everything you need to run. So right now it's just kind of a playground for you to get started. And if you do well, meaning if you turn out to be in the top 50 teams at the end of the stakeoff, subject to terms and conditions, you will receive, or you may receive, mainnet Celo Gold. So first off, I'm just going to talk a little bit about what a validator is, just to make sure that we're all kind of on the same page, and what it is specific to the Celo setup. And then I'm just going to give a quick little diagram of what the architecture is going to look like that we're going to set up, and then we'll just go straight through the docs. So Celo uses proof of stake, and there are two different classes of nodes, or two main classes of nodes, and one of those is a validator. And validators are a type of node that they communicate with each other, they propose, and they agree upon blocks. And they do this using Byzantine fault tolerance consensus. So as opposed to proof of work, where most nodes are pretty much on the same level, in order for proof of stake to work well, you need a limited amount of nodes that are actually participating in consensus. So in Celo's case, at the moment we have 100 validators at a time. And there is a notion of the current validator set. So you can be elected into one of those 100 validators that are participating in consensus. And in order to do that, you need to belong to a validator. So today we'll be setting up a validator in a validator group. And the incentive for running a validator is, of course, that you can earn rewards. So here, this is just like a quick little diagram, just showing that people can vote for certain validator groups, and then you get elected into the current validator set. So there are a few different things that you're required to run in order to be a validator operator. One of those, of course, is the validator itself, so right here. But there are additional steps that we would like you to, I guess, go through in order to be especially secure and also to bolster our identity system. So in this right here, we have a validator, and this is hidden behind proxies that are also run by a validator operator. And the idea here is if you're running a validator that's not hidden behind proxies, you can be susceptible to DDoS attacks if someone were to find your IP. And because there are only 100 validators up at a time or participating in consensus, this could pose issues for the network. And then also you could be punished for any downtime. So in the current setup, we only have support for one proxy per validator. And this is going to change soon. We have work to allow multiple proxies, but for the time being, it's just one proxy. But the idea is that the proxy is kind of a bridge between the validator and the rest of the network. So that proxy is listening on an external interface, a port that's accessible to the outside world, and that's what's peering with the rest of the network. And then it has a port that's listening on an internal interface internal meaning on the private network that only the validator is able to peer with. And I will go into details on what those ports look like in a moment. But another thing to note is right down here, attestation service. So that is how we allow users to use their phone to claim a Celo address. So for our app, we want users to be able to map their phone number to a Celo address. And that attestation service will send little attestations and little challenges to a certain phone number using something like Twilio, so a text message, in order to verify that a user really owns an address. So a little bit more detail on the proxy setup. It's super important that these specific ports are opened on your firewall. Otherwise, there will be problems getting your validator to connect to the rest of the network. So in here on a private network, we have a validator. This validator shouldn't have an external IP address. So no static IP, no public IP, only an internal IP address. And it communicates on its port 30303 over TCP to the proxy, which is listening on this port 30503. And again, there should be like no way for the validator to reach from the outside world. And this is for a couple of reasons. It's DDoS protection, and then also in the event that your validator has privileged information, it makes it really hard for some random person to try to make your node do things you don't want to do. And then the proxy here is listening on port 30303 to the outside world, and it's using TCP and UDP. So the reason why we have UDP here is that's how discovery works. So discovery uses UDP, and then pretty much all other protocol level communication happens over TCP. Cool. So just to cover what is involved in running a validator. So this is pretty much just like a summary of what we have in the docs, and we can really just follow pretty much exactly what's in the docs, but just to cover it briefly. First off, you'll set up your accounts. So that's like your validator account, your validator group account, your proxy account, things like that. Then we'll set up the proxy. So we'll actually get the proxy running, syncing with the rest of the network. Then we'll run our validator, get that using the proxy to sync with the rest of the network. And then we use, we have a CLI, and we'll use that to register the validator and the validator group. Then we'll stand for election. We'll vote for ourselves. So yeah, I think my plan now that I've covered the basics of what I've already set up is to just kind of go through this document and then show what I have done, what I haven't done, and then maybe give a little bit of a description of what's going on. So one thing to note is that we use a lot of environment variables in the docs. And I really recommend writing these down somewhere. So either like in a random file in your notes. What I ended up doing is just putting it in my bash RC or bash profile, just to make it easier on myself. You're dealing with a lot of different machines in these instructions. So we ask that you have, or I guess it's expected that you would have your proxy and validator be on two different machines rather than running on the same one. And then also there are some instructions for running a node locally to communicate with the network and register for some things. All right, so going through this, I actually already have these in my bash profile, so I don't have to worry about that. And then this is the instruction for pulling the image that will actually run the node. So it's same image, same code for the proxy and the validator. So in here, there are some instructions to run a node on a local machine. And the idea here is that you want some keys to only be on your local machine and not to be on your validator or proxy. So what we'll do later is we'll create the accounts for the validator and the validator group on your local computer. And then we'll use that to authorize different accounts, or I guess one different account, which will be the account that will actually be signing blocks on your validator. So the idea is you want like the master key pretty much to be on your local computer so you have more control over it. So just following this on the local machine, we'll be creating the validator group address and the validator address. So I've already done some of these steps, and I will go on my local computer, which is on the bottom right. So I'm in that directory. See if I can make this better on myself. And just to make sure I have this environment variable set up, which I do, that's the correct image. So just running this command, and then it'll ask for a password. So it's really, really important that you don't forget this password. The password itself isn't used for securing the account entirely. So if somebody like finds out your password, but they don't have your private key, you'll be fine. But this is to make it so that way you can unlock accounts on a node, which means that you would be able to have a node use your account by default and then use the funds on that account without any kind of special permissions. So this right here, we have an address, and then we would want to set this to Celo validator group address, for example. I've already done this. If I show here, and I did this that way I could give myself gold to begin with. But yeah, the same exact idea for the validator address. And I already have that set. So next we'll actually start the node on your local machine. So this first step right here will set up the Genesis file, the correct Genesis file for the Baklava testnet. This step right here will use a static nodes file. So what that is it's like, it's I think a JSON array of a bunch of enode URLs, which are like URLs to other nodes in the network that we can use to connect to really easily, really quickly. We are able to use the boot node also, but just because it's not super high priority, and this is a temporary node, we're just using a static nodes.json. So I want to run that. It might complain actually. Yeah, okay, so I have this node running in the background pretty much. So if I stop, and this is because I've already done these instructions. Cool, so I should be able to run that. Looks good. And then run this down here. And then finally, you can just copy and paste that whole thing. I already have that Docker container, so I'm just going to start it up again. So at this point, it might take a while for it to sync with the rest of the network. I'm not sure how many blocks we're in so far, but I think at the time of saying this, it's probably somewhere around like 90,000 blocks. So it might take like a half hour. Can't really guarantee it, but I've done this ahead of time where if I were to look at what block we're on, I can do that using the geth console. So the container name is Celo accounts. And there's a command called geth attach. Actually, I think I can just do attach. Maybe I'm doing something wrong. There we go. Okay. And I can look at the block number. and we can see that I'm still syncing with the network actually. So it's kind of increasing at a pretty fast rate. So I think for now we can kind of just let this sit. The intent is to have it sync in the background while we do some other steps. But if you've gotten this far, it's good because you're running a node in the network, which is pretty exciting. So next step, we'll focus on the validator. And similar to before, these environment variables I've already set in the bash RC. So I can actually show some of these. So a lot of these we haven't seen yet, but yeah, you can see that I have the Celo image, validator group address, and then we'll create the other ones soon. And I already have this directory called Celo validator node. So these directories are what we call data directories. So this is what the blockchain client will use for all chain data, your key store, so it'll hold any private keys, and then really any other information that the node needs. So it's really important that when you go through these instructions, as you can tell here using PWD, present working directory, we make an assumption that a lot of these instructions are run from inside your data directory. So you don't necessarily need to call it Celo validator node. You can call it whatever you want, but you just need to make sure that you keep it consistent and that you're always running these commands from in there. So same thing as before, we'll run this same command. And this is to create the Celo validator signer address. So like I said before, this is not the address of your validator, but this is the address, or I guess an account, that will be later authorized by your validator to sign blocks on your behalf. And it's just better to, it gives you the ability to, I guess, withdraw this permission or this account's permission to sign blocks. So on the validator machine, I've already set this. And we need to run this command to generate a proof of possession. And this will be used later on. But what this does is it requires your password. So yeah, this basically gives us a signature and a giant public key that we'll want to save for the future, which we do right here. And this should be deterministic. So if I sorry, this is on the local machine. So yeah, we'll want to save this on the local machine, which I have already done. And I just want to verify that I have. Cool, looks right. So just to clarify, the validator signer signature is this field right here. And then the signer public key is this big thing right there. And then we want to do the same thing, but for BLS. So that BLS flag. And then put in your password. And then it'll also spit out a signature and a BLS public key. And just to make sure that I've done this already. That matches up with there. And those two match up. Cool. So before we really deploy a node, a validator node, we first need to deploy the proxy. And the reasoning here is that we need some information of the proxy node that's running in order to start up the validator node. So what we'll do, there are some command line arguments that each has that indicates, one, if it's a proxy or if it's not a proxy, and also what the proxy information is. So one thing to also note is you really don't necessarily need a proxy. It's totally possible for a validator to just be connected to the rest of the network directly. It's just not really a good security best practice. And personally, I wouldn't recommend it. But it is totally possible. I do think that there is merit in having a proxy though, especially once we add multiple proxies. So there are a lot of, I guess, repetitive steps going on here. So if we go back to the proxy, or I guess the proxy for the first time, same thing, these environment variables I have saved into the bash RC. Whoops, that's weird. We have this data directory for the proxy. And then we want to go through the same steps that we did when running the node locally. So I think I should already have a node running, which I can just stop for the time being. Ooh, I don't know what that is. That's weird. I'll ignore it for now. So I'm just going to stop the proxy. And then we can run this command again once it's fully stopped. And that initializes the Genesis. Successful, nice. And then do something similar with the static nodes. And then down here, we'll actually run the command to start the Docker container. So on the proxy machine, we will also need to know the Celo validator signer address. So I'm just going to make sure that I have that. Cool. And then this whole command right here will actually start the container that will restart if it were to crash for whatever reason. It listens to these specific ports that we've already covered. So 30303. It is totally possible for anyone to change these ports, but just be aware that you would need to change them everywhere. So on the firewall, in addition. Going through it, we have our network ID that's specific to Baklava. We indicate that this node is a proxy, and we indicate what the address is of the validator, and that's the validator signer address. We indicate what port we want the proxy to listen to internally, or I guess on the private network. And right here, it's important to, you can set this to whatever you want. So we have, there's a website called, I think it's like baklava-eatstats.celo-testnet.org. I can actually go to it. And this will show some like basic network stats of validators in the current elected validator set. So if you see here, these are all nodes that are in the current validator set. Some of them aren't, some of them are. But the name that you're putting in on the command line, it will be what will show up here. So Baklava proxy-9, that's a CLabs run proxy. But we can set whatever we want here. So I think I set it to like Trevor or something like that. I can, that's not how you spell trunk. Oof. All right, it's not letting me scroll for some reason, but basically the idea is there's not a lot to change, and you can run that command, and I'm just gonna start up the one that I've already run. And the reason why I did it before is it just takes time for this to sync, so didn't really want to sit around for that during the webinar. So one thing we need is the E node of the proxy. So this is like comparable to the public key of the proxy. Like it might actually be literally the public key. But what this will do, if you print this out, is it will print this giant thing. And we'll need this in order to specify on the validator node some information about the proxy in order for things to get set up. So we have that. This is a quick little blip on, I guess, the networking aspects of what's going on with the proxy. I think I've already covered it. I would suggest, if you're watching this recording in the future, to take a look at that diagram that I had where it showed the specific ports. But what you really need to know is proxy enode, which we just got, the proxy external IP, which you can see just by going to right here in our example, and then the internal IP, which is just that. Cool. So this involves testing our port setup. To be honest, I'm not totally sure if I have telnet on this computer. Aha, I do. Okay. So let's see if I have proxy external. Doesn't seem like it. So what this will do is just like test to see if with this port, this port and that IP address, if TCP connections will be accepted. And this is from my local computer to the public IP address of the proxy. So it says we connected, nice. And I just disconnected. So that's good. On the validator machine, we want to be able to test if the proxy's internal port is accessible. I don't think I have telnet on here. I don't. And because this has no public IP address, I'll have some trouble downloading that. But given the current setup, I'm very confident that it will work. But I definitely recommend, if you're doing this yourself, to try to test this out just to make sure. It'll solve a lot of headaches. So back on the validator, hopefully by this point, you remember your validator signer password. So we need to put this inside a file. I have that file. And in there, that's where I have my password. And then we're, again, going through the same steps where we're going to be deploying the actual node of the validator. So we need to init with the Genesis. We don't need to worry about static nodes or anything like that because we don't want the validator to connect with any nodes apart from the proxy. And then this command right here, similar to starting up the proxy, it'll start up the validator. Listening on these ports, it will be mining. So what that means is that it's a validator and then it will try to participate in consensus. We don't want discovery on at all because we really only want the validator to be peered with the proxy that you're running. We indicate that it's proxied. And then right here, proxy enode URL pair. This is where we specify information about the proxy and how the validator can connect to it. So this first section, so it's split by a semicolon right here. This first section is the enode URL of the internal interface of the proxy. So that's using the internal IP address and that internal port. And this will be used to have the validator initiate a peer connection with the proxy directly. And then the second part is what would be seen by an external node that is connected to the proxy. And the reasoning here is when you're a validator in the active or the current elected validator set, we want these validators to be peered pretty much directly with each other. And so in this setup, what's happening is we have the validator that's only peered with the proxy, and then the proxy is peered with all of the other validators. And this is gossiped to the entire network, and only the elected validators are aware of it or able to, I guess, decrypt it. And they use this information to initiate a peer connection with this proxy. So it is super important that these two enode URLs are correct. Otherwise, you will definitely run into issues becoming a validator or validating blocks. So this right here, I touched on this a little bit before, but this is unlocking an account for this node. And then you're giving it the password for that account. So what this will allow is any transaction that happens on the node that uses this address, so like sending any sort of funds from that address, it'll be like auto signed basically. So it's really important that no one else has access to this node with an unlocked account on it. Otherwise, you can definitely lose some funds. And then same thing as before, you can set your validator name here. And in a proxied setup, this won't be what actually shows up. It'll just be your proxy. But yeah, so that's everything that you need here. And I already have a node running here. Okay, so at this point, just to check, it would be good to make sure that your validator is connected to your proxy and only your proxy. So we can do that similar to what we did before, where I exec into this container, and then if you run get attach. Okay, so that's a pretty high block number, which is good. I think that sounds right to me. But what we can do is, if we run this, we'll see that it's slowly climbing at the rate with the network. So that's very good. That to me implies that we're synced with the network. And then I want to make sure that I'm only peered with my proxy. So if you run admin.peers, it'll print all of the peers on an account. So we can see I only have one peer. This is on the validator, and it is for proxy purpose. So that's peered with my proxy, which is very good. So at this point, we're all set up, at least on the infrastructure side. And then it's a matter of running some commands to call certain smart contracts to get our validator up and running. So at this point, we'll have to install Celo CLI. So this is just a CLI that will interact with certain smart contracts. And the way these instructions are set up is the CLI will send these transactions using that initial account that we set up on your local machine, or that initial node. So there are some instructions in order to download Celo CLI. You can do so using npm. So what I've done already is downloaded it. And personally, I've run into some issues using npm install-g, which installs it globally. So what I did is I just did it in like a random directory. And in here, I have it living in here, you can see I have Celo CLI. But I have this in my path. Oops, didn't really mean to exit. I'm just so used to VMs at this point, I guess. So I'm going to go back into my Celo accounts node, so my data directory. And if I run Celo CLI, looks like I have it, which is good. So yeah, first I'm just going to check my account balance. So if you're following these instructions, in order to get Celo Gold, you'll need to go through a process in order to get fauceted by a human. I've already done this just to make sure that it's a little bit easier to demonstrate what's going on. But if I run this, I should have some funds, some Celo Gold. Cool, so I have a bunch of Celo Gold. This is 12,000 Celo Gold. And the reason why it's expressed so highly is it's expressed in units of 10 to the negative 18th. So that's like analogous to Wei in Ethereum. So we have Celo Gold in the validator group, and then we should have Celo Gold in the validator as well. Cool, so we both have the same amount there, which is perfect. So first we're going to run a command that unlocks our accounts on our local node. And it will prompt for my password, I would hope. Cool. Okay. Interesting. Okay. So I think there's a certain RPC, which stands for remote procedure call, on this node that isn't exposed, which should be. So what I'm going to do is I'm going to see what it was run with. It might be that my Celo CLI is configured wrong. So maybe I'll try config set. So I'm thrown off by it saying I have personal here. So I'm going to try this again. Cool. That's good then. What I probably did is I had my Celo CLI pointing at a different remote node. But this setting it right here points it to our local node. So going to do the same thing for the Celo validator address. And I would definitely recommend picking a password longer than 2 characters, but that's what I had to do to remember it. Okay, so right here, we are going to be registering our validator group and our validator. I guess registering the account. So this name right here is anything that you want to put. So I'm just going to put, Trevor group. Awesome. And then I'm going to do the same thing for my normal validator. And these names are just used to show up in the CLI and in a couple other places, but they're not super, super important, but they will be used. Cool, so we already ran those. And then now we can just confirm that we've already done that, or that it worked, I guess. So awesome, it has my name, Trevor group, for the validator group, and then how's my name for the validator, Trevor validator. So this right here, authorized signers, I talked a little bit about this before, but what this is you can authorize certain accounts to do things on behalf of this account, which is what we're going to be doing to authorize the validator signer account. So we have a notion of locked gold, and this this is used to I guess allow, you're putting up something at stake in order to run your validator or validator group. So this could be slashed if you misbehave, and you need a minimum amount in order to run a validator or a validator group. So the minimum amount is 10K Celo gold, which we meet. We have like 12K Celo gold, but we're just gonna follow these docs. And you could do more if you wanted, as long as you leave some Celo gold for making transactions. But we're gonna try this out now. So this is locking up that Celo gold. Cool, so it worked. And then I'm going to do the same for the validator account. So that both the validator and the validator group will need to lock up Celo gold in order to be eligible. for later steps. And then again, we can just confirm that it worked using locked gold show. Awesome. It says that I have about 10,000, which is great. Locked up for the group. And then same thing for the validator. Cool. So now we're going to be running for election, which just involves running this command right here. So this is what I was saying earlier, where you can authorize a different account to do things on your behalf. So in this example, we're authorizing the Celo validator signer address to be the validator. Cool. And then we can confirm that it worked by checking, what was it? Authorized signers. Cool. Authorized signers, if we see under validator, this account is different and it should be the value for the Celo validator signer address. And it is. Cool. So right here, we're going to be registering our validator group. And then we're also setting the commission. And that could be set to, I think, something between, 0 and 1. Cool. And then same process of just confirming that it worked. And cool, looks like it worked. Commission looks right. Looks all set. And then now we'll do something similar to register our validator. And this is where we're pulling some different environment variables that we set a while back. Cool. And then right now we're going to have the validator try to affiliate with our validator group. So it's a two-step thing where the validator will say, I want to be affiliated with this validator group. And then after this command, we'll run something where the validator group will accept that affiliation and make that validator a member of the validator group. Cool. And then now we will accept that. And then now we can just check to make sure that those worked. So we can see on the validator side that it is affiliated with this account, which should be what was it? Celo validator group address. Cool, so those match up. And then if we get some information on the validator group, it should say that it has a member, which is our validator. So that guy right there. So now we're going to be actually voting for our validator group. So you only vote for a validator group. You can't vote for specific validators. And we're going to be voting from our validator address and our group address. And it does this using the locked gold. So So this right here, you're using the Celo validator address to vote for the Celo validator group address. And then this line right here will do the same, but having it vote for itself. Cool, and then keeping with the pattern, we'll just check that everything went successfully. So it has a total of 20,000 votes, which makes sense. That's the sum of the two that we just did. And it's eligible, which I think means that it has at least one validator in it. That's one of the requirements. And if we show, yeah, so this is the behavior of the validator group, what it voted for, and then same for the validator address. Cool. So what this does right here, so this is enabling the validator and validator group to earn epoch rewards. So at the start of a new epoch, I guess, or the end of a new epoch, rewards are given out to certain accounts. So like the validators and the validator groups. And this is what will enable that. So I think what might be happening is this is waiting for, let's see, this must be done every time new votes are cast and can only be made after the most recent epoch has ended. So I guess this is going to be waiting for the next epoch, which we can see on each step. How long that'll be. That's kind of a long time, if this is accurate. 300 blocks, 5-second block times. So we can kind of let this sit for now. And just kind of wait until that would happen. So at this point, assuming that this goes through and we run these commands afterward, it seems like we are all set and that we have a pretty solid chance of being elected into the current validator set. And we can run these commands later to just show who's elected. And then similarly, there are some commands to see how your validator is doing. So this command right here will say how many blocks it's signed recently and if it's elected. So that is helpful in understanding if everything really is set up altogether. And at this point, we can make our way to the attestation service. So I know that we're close to 9 a.m., or I guess 1 hour. Claire, do you think it's best to cut this down or should I continue going with attestation service?
I think we're good. We have scheduled another 45 minutes.
Oh, cool.
And don't have questions have been answered whilst you were talking. So we should be good to go. Continue.
Okay, awesome. Cool, so now we're at the attestation service. So what I've done as preparation for the attestation service is really similar step to before. I created a VM. I decided to create it a little bit smaller, but it seems like Google Cloud is complaining, so maybe don't do that. So I have a new VM, I've installed Docker on it. And I also have created a database on Google Cloud using their SQL service. So attestation service actually does require a database of some sort. So I think it allows MySQL, Postgres, and then SQLite. So I set up Postgres. and I have this database here. And if we go to the docs, I can explain probably a little bit more. Cool. So what the attestation service is going to be doing is it's going to be receiving, it's going to be listening on a port, pretty much like an HTTP port. And then given certain conditions, it will fire off a text message to a number in order to help prove that that number owns a certain address. So we have two recommended, I guess, providers for sending text messages. And that's Twilio and Nexmo. I went ahead and signed up for Twilio. I only have the trial as of now, which I hope won't be a problem. I haven't used Twilio before, so this will be exciting. But I have already signed up for it. And I think if I go to Twilio console, should be able to show it. I don't remember what email I did, to be honest. I can try that. I don't think it's liking it. I feel like I might have done it with the account that I did here. Ooh, looks good. Okay. And I will set that up later. Cool. So I have a trial balance and then a trial number that I've set up. And I guess we'll come to that in a moment. But first we can get started with attestation service. So attestation service is still going to be running a node. And we'll pretty much go through the exact same steps that we've done in the past. So we have all of these environment variables. We have our validator address. And then we have our data directory. So right now I'm just going to SSH into the attestation VM that I have, which is right here. So if I ls, you can see that I have my data directory. Then in here I have a bunch of data. And same process we've done before. So we're initializing with the Genesis. We are setting up static nodes. The instructions should be updated soon to have us use a boot node instead of static nodes, but for now it's static nodes. And then we're creating a new account that we will call our Celo attestation signer address. So I should already have that guy. There we go. So I had the Celo attestation signer address already, but I haven't done anything to authorize it yet. And then similarly, we'll run the proof of possession. And I should have already done that. So you can run this command. And then it'll give us the signature and the ECDSA public key, which we want to save on our local machine in these two environment variables. So I want to make sure that I keep this terminal open for now on my local machine. It's getting a little confusing with all these panels, to be honest. Just going to move that over. And then on my local machine, I just want to make sure that I already have the signature and then also the signer. Or that's the signer address. Yeah, cool. That's what we want. So now we can go ahead and authorize this address for the role of attestations. And try that out. Perfect. And then similar to what we did before with the validator, we will need to put our password for our account that we created into a file, which we then pass in the command to actually run the node. So I think I might have already done that. At least I hope I did. Cool, so I already did. I have faith in myself that I put the correct password in there. And then just to go through the command to run the attestation node, we always want to restart if it were to crash for whatever reason. We're listening on this port, so 8545, and this is different from, so this is more of a Dockerism, but it's exposing it so that we can use that port. And this port is used for RPCs, so remote procedure calls, and that allows you to just do certain things to a node, run certain functions. So when I went in the geth console, when I typed geth attach previously, and then I was using like admin.peers, that's an RPC. So that's an example. And then you can change what RPCs you want to be able to be used using this port. Network ID, we have the correct network ID, sync mode full, RPC that enables RPCs, and then all of these APIs we want to be able to be used. So it's really important that we probably don't expose this port 8545 externally, otherwise people will be able to use all of these RPCs. We want to unlock the account and then use that password. So I think I've already done this. As you can see here, so Celo attestations, and this is the Celo node image. So it's already up and running. I can do what I did before and just kind of make sure that it's synced. Looks pretty good, just to confirm. Cool, so that number, jump to that number, seems like it's coming along well. And then I can do admin.peers.length to see how many peers I have, which is 5, which is good. Cool. So next step is to actually set up the attestation service. So this is just like a node service, different code base from what a normal node is running. And I think I should have already set this, but I just want to confirm. Cool, looks good. And then right here is where I would have set up for Twilio. And I've already done that, obviously, and I should have all of these. I think the other ones are like semi-private, so at least this one probably is. But I have faith that I have it. I guess I could just do this. See if it auto, nice. Cool, so I have Twilio, I have everything set up, and then I can keep going. So here we come to the database configuration. I have already done this as well. So if I go back to my database, I chose to use Postgres. So I have this environment variable. Or should, yeah, okay, there we go. I won't print it out because it has my password and stuff in there, but if I go back here, pretty much all I did was I created a new SQL instance and then like made a Postgres. And then I have, if you go to users, I'm just using the default user Postgres, and I changed the password to something random. And then I configured it so that way I can have this database instance be accessible using a private IP address. So I have this actually on my Celo VPC network that I created over here. So this private IP address is within that VPC network. So that means that any, yeah, you can see right here. So that any instance that's also on this network can just use that private IP address to reach it. So I went with that approach and came out the other side with a big database URL that looks something similar to this. So right here is pretty much what I have. So Postgres being the user, database password. I changed the IP address here to that internal IP address, kept that port. And then this right here is the name of the database. So if I go back here, I created just a new database called attestation service. Didn't put anything else in there, just only had that. Cool. So then next step is to deploy the attestation service, which again is that Node.js service. So if we take a look at this, I think it should actually show some things that indicate that it's node-based. So yeah, there's some yarn commands that we're running. It listens on port 80, which I come to think of it, don't think I've ever exposed on my firewall. And then right here, it's passing in all of these Twilio specific things that we need in order to actually get running. So I'm using the SMS provider, Twilio. I have my database URL, etc. So I've already run this, which can be confirmed by doing Docker PS. So it's been up for 18 hours. Yeah. So next step in order to do this is we need to register some metadata about ourselves. So what this is it will, yeah, so it will allow accounts to make certain claims without having to do so on chain. So this is actually going to be hosted on like a random place. I'm just probably going to choose like GitHub gist, but we can follow these through these instructions and then I can clarify later. So we're still waiting on this transaction down here, but back in my local computer, I'm going to do, wow, it's a big, there we go. So I think this created metadata.json. So cool, those are my claims so far. I'm gonna go into my directory just to make sure that I don't need to run anything else. Cool. So the attestation service URL variable stores the URL to access the attestation service deployed. In the following command, we specify the URL where the attestation service is. Okay, so I need to find this IP address, so this external IP address, and then it's listening on port 80. So that will be the URL. I think I lost it. There we go. Cool. So then I will run this. And then we can cat metadata.json again. It's looking a little bit better now. And then now we can claim the group address. So I think this is my first time setting up attestation service fully. So hopefully I'm doing everything perfectly. And yeah, it's looking a little bit better too. So we're just adding some more information to this metadata that we're going to have to post. Okay, so this is the point where we'll upload that metadata to anywhere that is reachable through HTTP. So I'm just going to create a gist. I think I need to go on Brave in order to do this. And then I'm going to see if it requires any specific name. Doesn't, which is cool. Celo attestations metadata. So I'm just going to copy this. And then I'm going to create a public gist. So this is on my public GitHub. And now we want this link, but we want to make sure that it's the link to the raw content. So make sure to click raw, and we can copy this. So I'm going to put this here. Oops. And then now we're going to register this metadata. For our particular address. Great, it worked. And then now we can confirm that our claims are accessible to everybody else. Does that look right? That doesn't look right. I'm going to wait a moment and then try that again. And I'm just going to confirm that this was the correct URL. Yep. So I'm wondering if this might have to do with me not exposing this specific VM on port 80. So I'm just going to add that really quickly. So I'm just going to check to see if I've already given it a tag. So these tags let me add a specific firewall rule for a specific instance. So it's Celo attestation service that I've already done. And then I want this to be able, or to be from any IP address. And I will have it on port 80. Oh, cool. Sweet. So yeah, running this command seems to work now. And I don't know if we saw down here, it looks like a new epoch just started. So everything went through on our election activation. I'm gonna run this again to see what this says. I'm not sure what that says. I'm gonna let that I guess we can try making it even bigger. How can we do that? Could not verify. Metadata URL. That's kind of annoying. I don't know how to make that bigger. Metadata URL could not be retrieved. Interesting. I am going to go back and just make sure that I did everything correctly. If not, I think we could just leave it for the time being. Yeah, I'm not too sure. Asa, have you ever run into anything like this?
Some people on Discord have, and I think the suggestion was to register a metadata file for the group, and then you should be able to verify it.
Okay, so just continue on with the instructions for now.
I think so, yes.
Okay, thanks. Cool, so I will go ahead and do that. Pick up where I left off. So I was running this earlier, and that's where I saw that issue. So I'm just going to go ahead and run this command to do the same for the validator group address. Cool, so I should have a pretty empty file called group metadata. Nice. And then I want to claim the account. Small again. Cool, so it's looking pretty good. And then we will upload it again. So I'm gonna copy it. I'm gonna go back to my GitHub. And I will create a new how do I do that? And then again, copying the raw URL. Awesome. It says now when you run Celo CLI account get metadata, you should see your claim for the group account to be verified. Okay. We'll try that out. Ah, okay, there it is. Thank you, Asa. Cool. So it looks like we're verified, which is awesome. And it says we have a valid URL. So yeah, I think that's the end of everything. I think there were actually some commands that I skipped to do with our validator because we were waiting. But I think these are just kind of viewing certain things. So what do we run? Yeah, I think if we just want to run these just to confirm everything's fine, it'd be helpful. Cool. I think we've actually run these before. So I'll try running this to see who's elected. I think this command's a little flaky, so it might fail on me.
Yeah, we fixed this in master, but it is flaky in the latest deployed version.
Okay. Yeah, it always fails for me.
Yeah.
Okay, well, I'll run this last command, and I think after that we could probably be at a position where we have the validator that's running that receive votes. Oh, look at that. So it looks like I am elected. I have signed 100 of the last 100 blocks, go me. And then I proposed one of the last 100 blocks. So it looks like we have everything running perfectly, which is super exciting.